All right, in today's video, we're going to be talking about 9.4, basic matrix operations. To be able to add or subtract matrices, I say that it's really just adding and then subtracting is like a negative. We'll say add and subtracting regardless. What happens here is the matrix order must be the same. So if it's a n by n, I can add that to another n by n. Right? If it's a n by n plus n by m, that's a no. It has to be the exact same size matrix. Now, when it comes to multiplying, multi, what's the rule? I guess it's the rule of multiplication, whatever. Um, the inside part of the orders has to be the same. So the inside order must be the same. Meaning if I have an n by m, I can multiply that by an m by n, since those are the same. If I had an n by n times an m by n, I cannot multiply because those are not the same. The outside actually tells you what size your answer will turn into. Right? So those are the real big things there. I can explain you using proofs and stuff, explain like why this is, but really and truly you just need to know how to do the operations. Your further math classes will go further in that. But today I'm going to be on page 610. I'm going to be on problem number 6. Problem number 6 says A plus B plus C if possible. And we are told that A is equal to 310, negative 205. B is 43, negative 2, negative 502. C is 2, 6, negative 3, negative 1, 10, 7. D is 3, 2, 5, negative 2, negative 4, 1. So I have my A is a 3 by 2, 3 rows, 2 columns. My B is 3 rows by 2 columns, and my C is 3 by 2, and my D is a 2 by 3. So to be able to add A, B, and C, they have to be exactly the same, and they are. So to add this, I'm going to add each thing in each element. So meaning I'm going to add A11 with B11 with C11. So that's going to be 3 plus 4, which is 7, plus 2, which is 9. And then negative 2 plus negative 5 is negative 7, plus negative 1 gives me negative 8. 1 plus 3 is 4, plus 6 is 10. 0 plus 0 is 0, plus 10 is 10. 0 plus negative 2 is negative 2. Negative 2 plus negative 3 is negative 5. 5 plus 2 is 7. 7 plus 7 is 14. And that's literally all you have to do. You just have to add each one of their corresponding elements. All right, let's do another. Let's do number 7. 2A plus 2B. A and B are the same size, so I can add them. All this little number on the outside means is that I'm going to have to multiply each element by that scalar. So before I can add this, I have to distribute this out. So this will give me 6, 2, 0, -4, 0, 10. So notice the 2 went to each element, and then we'll do the same thing to the other one. 8, 6, -4, -10, 0, 4. Now I'm ready to add their corresponding elements. So 6 plus 8 is 14. -4 plus 10 is -14. 2 plus 6 is 8. 0 plus 0 is 0. 0 plus -4 is -4. 10 plus 4 is 14. And that'd be it. Alrighty, let's look at another one. Let's look at number 11. Number 11 is 4a minus 3b. So again, same process. However, since A and D are not the same size, not possible. So before you go in through distributing, make sure when you're adding that they're the exact same size. Let's do a little extra here. I'm gonna call this extra. Now let's bring in multiplication. A times D. So for A times D, the inner ones have to be the same. So in this case, A is a 3 by 2 and D is a 2 by 3. These are the same, so it is possible. So let's talk about that. So A would be 3, 1, 0, -2, 0, 5. And then D is 3, -2, 2, -4, 5, and 1. All right, to multiply, it is row times column. Okay, so what that means is I'm going to take the first row times the first column, and that will give me the first element. So that means 3 times 3 is 9, plus -2 times -2 is 4. That's one element. Now I'm going to take row 1, column 2, and that result will go to row 1, column 2. So 3 times 2 is 6. -2 times -4 is 8. Then take that first row times that last column. So that's row 1, column 3. So that's 3 times 5, which is 15. -2 times 1 is -2. Now, if you want to go ahead and figure out what those are in your head, I'm good with that. I just want to show this one step for you. Now I'm going to take this row, second row, and multiply each column. And that result will go in the second row. So that becomes 3 plus 0, 2 plus 0, 5 plus 0. And then the last row becomes 0 minus 10, 0 minus 20, and 0 plus 5. Again, if you did all that math in your head, kudos, but you get 13, 3, -10, 14, 2, -20, 13, 5, and 5. Notice the answer was a 3 by 3 matrix, which is the outside part of your matrix. All right, while I still have this, one last question with this work. It's just another extra one. Can I multiply D times A? All right, so D is a 2 by 3, and A is a 3 by 2. I didn't even see that. But yes, they can also be multiplied. So I'm going to do that. I was thinking it wasn't going to work out. That's another problem for another time. But yes, so A times D can work. and D times A can work, but that does not mean this is the answer, because notice my answer will now be a 2 by 2. So I'm going to put this on the next page, but I'm going to use this same D and A. So D times A, again, that was a 2 by 3 and a 3 by 2 can work. So my D was 3, -2, 2, -4, 5, and 1. 3, 1, 0, -2, 0, 5. Same process. Row by column. 3 times 3 is 9, plus 2, plus 0. That's one element. Row by column. That's -6, plus 0, plus 25. That's one element. Row 1, column 1, row 1, column 2. And now we're going to go to row 2, column 1. So that's going to be -6, -4, plus 0. And then that's going to be 4 plus 0 plus 5. And then I'll finish with a 2 by 2, which is what the outside is. So 9 plus 2 is 11. -6 minus 4 is -10. -6 plus 25 is 19. And 4 plus 5 is 9. All right, so these last two were extra, but I want you to notice that AD does not equal DA. So multiplication of matrices is not commutative. The order does in fact matter. All right. Addition is commutative. A plus B does equal B plus A. That's a good one, but not multiplication. All right. That's going to come into play on our last section on 9.5. All right, so back to some questions out of the book. Let's look at number 30. It just says multiply if possible. So we have 5, 0, -3 times 4, 2, -6. This is a 1 by 3 because there's one row, 3 columns, and this is 3 by 1. It's 3 rows, 1 column. It can be multiplied, and my answer is going to be a 1 by 1. So 5 times 4 is 20, plus 0 plus 18 gives me the answer of 38. One row by one column. All right. Let's look at number 32, which is pretty much this flipped over. We got 4, 2, -6. And then we have 5, 0, -3. All right, this is a 3 by 1, and this is a 1 by 3. It can be done, and the answer ends up being a 3 by 3. Row by column. So that's going to be 4 times 5, which is 20. 4 times 0, which is 0. 4 times -3, which is -12. Notice each one of those are all separate, because this is row 1 times column 1, row 1 times column 2, row 1 times column 3. Now I'm going to take row 2, so 2 times 5 is 10. 2 times 0 is 0. 2 times -3 is -6. -6 times 5 is -30. -6 times 0 is 0. -6 times -3 is 18. And there you go. So it ends up being a 3 by 3. So again, order matters. All right, so let's do a few more, and then we'll call it. On this one, we're going to use A as -3, 1, 2, 3. B would equal 8, -5. C is going to equal 4, 7. Ooh, I don't know what that is. -2. And D is equal to -5, 4, -1, -1. All right, so the first one we'll look at is 39. which is a squared. A squared means a times a. So that just means -3, 2, 1, 3 times -3, 2, 1, 3. Can it be done? The 2 by 2 times the 2 by 2. The enters are the same, so this can be done. So again, row by column. -3 times -3 is 9 plus 2, row by column. -3 plus 3, row by column. -6 plus 6, and then 2 plus 9. 11, 0, 0. Ooh, 11. Nice. I wonder if that's a coinkydink or if that always happens. It's been a while since I've gotten to mess with some of these. Investigation for another day. Let's look at 41. 41, it says CB, but I want to try BC. All right, so let's look at BC. 8, -5, and where's C at? 4, 7, -2. This is a 1 by 2, and this is a 3 by 1. I've been trying to make one this entire time while we've been talking to try to not work, and finally I got one that doesn't work. 2 by 3 does not work, so this is a situation where it's not possible. If I flip this around, C and B would work because it's a 3 by 1 and a 1 by 2, and my result ends up being a 3 by 2. All right, so I wanted to get one of those. So now let's look at another one. So let's look at 47, and we have BD times A. Before I even do this work, I'm going to check to make sure it's possible. BD is a 2, oh, I lied, is 1 by 2. It's one row, 2 columns. D is a 2 by 2. So therefore, it is possible, and it'll turn into a 1 by 2. And my A ends up being a 2 by 2. So 2 by 2 is possible, and my result will be a 1 by 2. All right, I say check it because sometimes it won't work at one stage, but at least now you know what your result's going to look like, and you'll get a result. So it's sad to do all the work, and then halfway through you realize, oh, I can't even do it because I'm missing an entire row or column. You know, it's a little bit, but it's worth it, I'm telling you. All right, this will be our last one. After that, that's pretty much all your homework there. So this will be 8 -5 times D, because you have to do what's in parentheses first. All right, so row by column. That's going to be 8 times -5, which is -40 plus 5. Row by column. That would be 8 times 4, which is 32 plus 5. So I get my final answer as, oh, I say final answer. I get -35 and 37. Oh, that's not even a 7. Now I can bring in A, which is -3, 1, 2, 3. And it's going to be row by column. Oh, and that's it. I gotta pay attention to my own work. This is row 1, column 1, so that's going to be -40 plus 5. Row 1, column 2, so my next result should have been here, which will be 32 plus 5. So that's -35, 37. Again, trying to write a 7 like that. And now I'm going to bring in -3, 2, 1, 3. So row by column now. All right, I gotta get a calculator on this one. See, I know that's 70. What's that? Positive 105. Okay, and then 37 times 2. All right, so that's 74 plus 105, so that's 179. That's going to go row 1, column 1, so that's 179. And then I'm going to do the same thing here, so that's going to be 37 times 3 minus 35 gives me 76. Yep, perfect. All righty, so that pretty much is everything that you need for this homework. That's pretty much it with 9.4. We only have one lecture left before your final exam, and that will be 9.5, inverses of matrices. But if you have any questions on this, feel free to reach out and let me know. And that's all that I have for today. I will see you in the next video. Bye for now.